So, question. Who have the question one to come?
Oh, there's...
Please.
I don't have it fully formulated. Thanks. So first of all, thanks for the insights. Learned quite a lot of things, which I still don't fully understand, but I mean, that's normal. My question is, or my thoughts are that from a technological point of view, there is still a whole lot of challenge left to really get, the technology, for example, could work like a brain to really get into the direction of a AGI. And we've been discussing in IT management more from a non-scientific, but more from a really organizational point of view. We do things because they add a value to an organization, basically. And what I'm asking myself is, we take this into account. We don't do it for the sake of doing it, but for making something else possible, value creation, progress for the humanity. The question, is it worth the effort to reach an AGI when we're currently able to apply technologies for those hard cases? But is there a value in having AGI also doing the low sophisticated cases like turning the cheek, for example? Is it worth putting the efforts in, and what would you think would technologically be a way forward to really achieve that? I don't know if it was.
Yeah, no, I think it's a very good question. So, I might as well think about it for a moment before I start my ChatGPT answer that then isn't answering your question.
I've got a comment about it. John made mention of a roboticist, Rodney Brooks, that was at MIT for many years, and he's probably one of the, if not the most influential roboticist that you may or may not have heard about. He's responsible for iRobot, the vacuum cleaner, the automatic vacuum cleaner. Anybody use those?
Yeah, sure.
It's really useful. So to your point, what value creation, they're just very boring examples of robots that are really useful. So we exited from iRobot probably decades ago now. It's been around for a long time. Really useful. And that's his mandate for bringing robots into society, is that they've got to do something for us. So if you want AI or AGI, and if you want to create those characters like Elon Musk was doing with bipedal robots that look awesome, I can't remember what its name is, Oculus or something, they may not be able to do shit, but they look great, and that's what everyone seems to be absorbed with at the moment. What we're saying is, like, I think to your point, whether it's an enterprise application or whether it's a robot, what can it do for us? And generally those lower level functions the jobs that we don't want to do, they're the ones we want help with, not the knowledge, the fantastic thinking, the creation, the writing of books and the artwork. We want to do those creative things. Let's get machines. Let's get a Rosie the robot from the Jetsons to help us in your house before we worry about how it's more intelligent than the machine could be.
So that would mean that maybe we don't even know yet what we want to do with an AGI, but we want to have it, and then we find out how we can make it something useful. Is that basically your point? Or?
Yes, and I think Silicon Valley does a lot of that. We've got this technology, where can we use it? Instead of the other way around, well, what do we want to achieve? What do we want? Regulation or regulatory industries like medicine, finance, legal, they can't use the large language model or the large fusion models for a lot of the, certainly for interaction with customers, because it has to be the truth. It has to be transparent. It has to, it has to be 100% controllable and reliable.
Yeah, there's a scientific observation that's been made throughout the whole AI history as well that's relevant. Marvin Minsky was always saying we need more pure science coming into the AI field. So he's saying this in the 80s. We need to do pure research, work out some ideas, see what works, and then build on that. John Pierce, the Bell Labs guy, basically shot down machine translation and speech recognition by saying that this is just being done by mad inventors and crazy scientists. It's not being done properly. And because he was very influential, that was an AI winter followed, where the US government that was spending millions and millions on machine translation and speech recognition basically pulled the plug, and nobody could do it anymore. So the companies that kept doing pure research were like IBM. And IBM had this guy, Fred Jelinek, who is famous for saying, every time I fire a linguist, the quality of my speech recognizer goes up. And what he was doing was using statistics in order to get better results. So the technology was driving the science, and then the science was iterating around the same model. And where we're at today isn't the Silicon Valley model actually comes from Intel. Get a bunch of scientists together, a chemist and a physicist and somebody that's good at electronics, and then research how you can build useful machines. And it worked really well. People put money into it. If it fails, it fails, and then the founders move on to something else. What's supposed to happen is, until you actually have a product that works and people are using, it's not supposed to be funded much. It's supposed you get your $10 million, you build a thing out. If it works, great. If it doesn't work, then your company folds and you start again. And I think what's causing us problems at the moment is that there's $200 billion that's gone into generative AI, and they don't really have a product. They don't really have the science quite right. There's all sorts of gaps. And now you've got financial institutions driving the companies and the investors to go and do more, so their investment doesn't collapse. Because if a VC loses $10 million, it's disappointing, but they've got another 50 that might go up 10 or 100 times, and then they're making good money. But in this case, it's so leveraged that it's hard to go forward. But your point, your question is perfect, because that's exactly what should be happening. It should be getting driven by what works, and it should be a scattergun of any crazy idea you've got. Well, if you can at least convince a couple of other people that maybe it's going to work, then put some money in, see if it works, and if it does, that one's going to keep going. But otherwise, I just keep focusing on what there is an actual application for now, and try and build on that and make it work commercially.
Sounds good. Thank you.
Just take it. And then it's, yeah, boom. And then you go when no one comes.
Oh, that's not bad. Yeah, my question is, you told us a lot about this linguistic model and showed us this example. And I mean, you said the technology is very old. We have it for a long time. And it was never at the point that LLMs are now, and LLMs moved to that point where they are in like 7 years. Why should we use that technology that had 20 years and doesn't got at the point? Yeah, that's the question.
So the question is, because LLMs have been well developed, why don't we persevere?
More like this technology that you showed us,
right,
is there for a long time and it doesn't got there.
Okay, so there's a common term being used is good old-fashioned AI. So people are saying if it was done before 1990, it's good old-fashioned AI where you sit people down and they start writing the programs and things start to work. And if you find something that doesn't work, you write another program. And John McCarthy back in the 50s, founder of AI, was very strong on the idea, give me a problem to solve and I'll write a program, and then we'll have human-like intelligence by the end of it. And the problem with good old-fashioned AI is that it's based on computers. So you write your program, which is hard to do for certain, like vision. I don't know how you write a program for that. And the world's infinite. So take any language, you can write forever on any topic you like. I've done some statistics. I'm a mathematician at my core, even though I'm sort of against computers and the like. My father was the opposite. He couldn't do statistics, and he's a world famous statistician in education. So anyway, I now I've just lost my train of thought because I've branched too many times. So McCarthy was saying just write more programs, and it's writing infinite programs takes infinitely long. So what we need to do is something else. So up until 1990, everybody wanted to do good old-fashioned AI. In 1990, statistical methods are slightly better. And at the time when it should swing back to the old method, about 2010 or so, Geoffrey Hinton came out with deep learning, and it beat the ConceptNet. No, it beat the object. Yeah, with back propagation, he was able to get better statistics on the statistical systems. ImageNet was and so because he got 10% better on ImageNet, and he was trying to make his company popular, Google finished up investing in what he did. And once Google got a hold of it, they could use it in search. And so deep learning then went from slightly better at one statistical problem to being the core of the Google search engine, to then probably having billions of dollars a year spent on making deep learning do more and more. But that was the point when things should have swung back. And there's some great papers saying that we're not quite where about 2006, it's time for a big swing back. It's a paper called The Pendulum Swung Too Far. And we went from that to deep learning going about as far as it could. And just when maybe you're going to see the pendulum swing back, large language models come out. When we were actually promoting our service just at that point, and you couldn't talk to a VC because the next big thing is now large language models. And we're in the normal cycle, it's about 7 years. So if we wait for another 7 years before we try other things, then we're going to exhaust all of the problems that we have with the current tech, but not necessarily keep the rest of the industry moving that could be moving and being better. So at the beginning of all of that, I was saying that the Intel model is good because you invest in something, and if it does well, it keeps going. At the moment, we're investing in things that aren't solving the problems, and nothing else is being invested in because all the money is being tied up with that.
So the one word would be investment. And now we're getting a word out there now about there's alternatives.
Yeah.
There's something happening actually. So the basis of the large language models are neural networks that exist since the 50s. So we have this technology, which is not new. It is a very old technology. What is happening since the social networks and Facebook, for example, Twitter, etc., is the amount of data we have with which some machine learning algorithms work very, very well. We have a lot of computer power, which was not possible before, so very powerful multiprocessors, NVIDIA, multi-core systems, etc., that give the algorithms the possibility to answer very, very fast and have the answers back. And we have also a lot of other complementary things like open source, open publications, the code you can download and start working. And this has been developed now in the area of machine learning, large language models, very, very fast, because that was, for example, Google Brain with the ImageNet and the transformers, etc. architecture, they were working on Google. So it was like a big, but the other ones were not developed and with no investment. So what always was the case, everybody competed together. For example, genetic algorithms, a lot of other different algorithms that were on par with machine learning, they suddenly has no investment anymore. So what we see is, wow, we have a new technology. But actually, what we have is more investing in one of the areas, getting attention, but not the other. And that's a huge problem because all the focus on only one part. And we think, well, LLMs and keep improving LLMs, and we will have powerful systems. without investing in the others that are maybe better. We don't know. That could be maybe fixed with LLMs. We don't know, because only there is one direction now. So that is something that is moved by money investment. So we have the AI winters already. The AI winters is when financial support for the other areas that need this development is not there. Like in the 80s, like in the 70s with the other AI winters, like 1999, etc., where talking about AI or about machine learning, oh no, better don't mention that in the grant because you don't get the money. And now it's the other way. So everybody wants to do something with AI, but only very, very narrow focus. Yeah? So it is like a mission to because we need that to make progress in the area.
Could I make one more point, which is after I built this system in 2006, I got to the point where I knew that I didn't understand how English worked, and then I found role and reference grammar. So since that point, I've integrated a whole bunch of role and reference grammar things, which then creates questions of what our semantic model, the meaning-based model, should be. And one of Van's colleagues at Heinrich Heine University says, that's his specialty. And so I got his book, and then there's a whole pile of new things that we could already do with a solution. So that what I think should happen is that the system that I built should now be getting expanded and get people with special expertise in areas working out improvements for it. And so it's not the good old-fashioned AI stuff that I'm doing. It's that plus all these other things that have been built up since, and then extensions that you can see that you're applying older theories to. And that's where our progress, I think, comes from.
Is your research open source so others can look at it and try it out?
I've got 2 key patents on it because we were in the older days looking to get a system built that actually worked, that was generic to multiple languages. And once we got the second patent finally approved last year, we could actually do a license of some description. And I'm thinking universities would be great for that, because I've shown you like 5 minutes of something that would take a few hours to go through just to get a feel for it. And people at a university like this would be actively researching and improving. So that's one of the reasons I'm happy to talk more about that.
Yeah, because I think it's an important point, because we can download an LLM on our computer, a very low quality one, and just use it, try it out, and get a nice feeling for that. And these other technologies are so far away. I am a coder. I just like to write code and try something out, and it's other technologies are very far away now, because LLMs are so easy to get in. I find this also a huge problem.
Yeah, good point.
I would. Okay, I also come. It's rather a comment than the question, or that's a comment on your question, which mingles a little bit with a question I was trying to formulate, but I couldn't reach to a conclusion. And that is like, basically the main problem that you have with the downloaded LLM is that they do counterfactual hallucinations. So they have been built with millions, billions of data sets. They have a statistical knowledge they can express well, but they cannot very well talk about truth facts. And that is because when you start to argue with them, they usually have all strains of input that is not exactly true. So what I think what is a good advantage of the theory that you are following for so many years is that these patterns might be a much more slim representation of truth. So this concept of world knowledge can probably, and I will come to a question. So this world knowledge can probably be represented in a more slimline fashion with patterns. So if we take that human brain paradigm and we kind of extract, for instance, from reliable text, but much less reliable text than all this huge text, in a very intelligible way, these patterns with your software, for instance. And I'm not proposing to release it, but I'm just saying even the conceptual idea might be a good extension so that we don't need to waste also so much energy anymore to build more and more large language models. And therefore, I think it's a very, very good. I have a question here myself, and that is, do you not think that probably you could use existing LLM models as agents to support you to apply your theory? Do you know what I mean? This is my question too.
It's a great question. One of the companies we worked with was David Ferrucci's company. We did a project for One World a few years ago, where they've got their round the world ticketing system, and we built a front end for it that then was much more targeted using linguistic capabilities. And Dave said that back in early IBM days, because he was the top engineer at IBM, what they did was they used the best parser in order to generate data, in order to put it into the statistical systems, and that was the best thing that they could do. And I was sort of feeling a bit offended by that, because I haven't built this thing to be driving something else. But no, in any type of system that could generate accurate examples that we wanted to use would make sense. And the hallucination problem coming out of the LLM is probably unsolvable. But the argument that I've made on the internet recently is, if you're going to use the pattern-based model or the RRG, role and reference grammar model, rather than train the system that's going to be helping somebody with, what sort of shoes to buy or some sort of shopping thing, rather than training it up with nuclear physics and all of the mathematics in the world and so forth, it would be much better just to put in the relevant knowledge that it needs. Which then raises another very interesting question, because people often talk about facts. And the problem I've got in the modern world with facts is that the facts are always in context, because any time you look at media, you can get diametrically opposite facts, which basically means one media outlet says this, another media outlet says the opposite. And so the fact actually embodies the context as well. And when we make a decision on something, we're actually using not the fact itself as much as we're using where it came from, the context. So if I read something in the New York Times, potentially I'm more likely to believe it than if I read it on the internet on some scrappy website.
I mean, Kahneman that mentioned was earlier, much earlier, talking a lot also about human bias. And,
yes.
We know that humans are even having the problem that they are not necessarily creating the right conclusions from the facts. So
right.
This is a big problem. I mean, how do we reason? How do we actually represent so-called world knowledge? To which extent can we do it intersubjective, etc.? This is another question I have. How can we actually create better knowledge base?
Yeah, and I think the answer is we often hear the world-class computer scientists like Jan LeCun at Meta. He'll make some comment like, we don't know how the brain works, so we can't do anything. But the people with the expertise in the brain science aren't the computer scientists, even though I'm a computer scientist. But what we want is to have exactly that debate amongst the people that have spent their lives understanding it and improving on it, and then use the output of that to train the other people that are struggling with that problem. Because then you've got all these good balanced perspectives to bring to bear.
You agree, by the way, to the way to say that there is no AI winter, because I think we are feeling it's a winter because it's a winter of funding going only in one direction. But I think we are already feeling that this direction is slowing down because we are missing what now needs to come up. Exactly what we just talked about.
Yep.
There are a lot of things to investigate in that area.
But you said that we should try not to train LLMs with data about physics and stuff like that. If they want to sell shoes or something, and it's a bit of a crappy source. But I heard on a podcast that they tried to train an LLM only on scientific papers,
Yes.
and this LLM was so much hallucinating and so bad, and an LLM with a comparable data size but with a much more untrusted data source like Reddit is much better without hallucination stuff and so on. So
Yeah, for LLMs, bigger does seem to be better. I agree. Yeah. Or up to a point. But it's got this fundamental, like the word vector model and the transformer model has got fundamental limitations in it, and
yeah, of course.
and that's not something that gets debated a lot in the online community, because it's a hard debate to have, because you have to. It's funny. I have spent a lot of my time explaining how deep learning works and how LLMs work, and it's not my specialty. I'm sort of the counter, but people say, but won't that solve all the problems? And
You pointed out, Thomas Dietrich said this, going forward, we should be looking at separating out the language interface, the linguistic skill, from the knowledge base.
yes,
That's kind of what we're talking about here. Like, the facts are that Wall Street Journal says something, and then that New York Times says the opposite. That's still a fact. That so long as you're citing the who said what, you're not. So why don't we get machines like John's proposing, that you work on the language interface or the linguistic skills separately, and your knowledge base is like, for an enterprise, it's all their data, it's all their information, their enterprise information. With the language interface, then that can understand it. Does
That makes perfect sense, but it's not only about the Washington Post; it's also about the Hindustan Times or the the Novaya Gazeta in Moscow or whatever. So you have lots of perspectives that are using very different information.
Yeah, and maybe that's the big internet problem. Still, when you're separating out, if you're getting machines to do what they're good at and using the humans for what we're good at, like a spreadsheet is superhuman in what it does. So we're not going to try and emulate do that, but a spreadsheet will never won't make a mistake in calculation.
There's simply different types of knowledge, right? Knowledge that can be traced down to a pure, reliable source, and knowledge that cannot be traced down to an actual, factual, absolute truth.
Right, to pinpoint where it came from.
That's the one thing. But the other thing is, a lot of knowledge that we hold is not factual.
Opinion.
LLMs are amazing.
Or even from sources that you trust, however the article is later retracted.
Yeah.
Trust the source.
Yeah.
And the publication of this article, but then after some insights, it is retracted because of something else. So what do you trust is also a huge question.
And stuff like that is for an LLM very difficult because they can't forget. You need to then train a new one and be careful that this old data is not in there.
And this is very
difficult.
Yeah, that to. Any other questions? Yeah, come to me.
Okay. So that I can list all the discussion, but
It's okay. We're slow formulating our answers.
yeah, okay. You try. Okay. And I mean, so I try to make sense of how you approach and maybe so it's like more a dialogue where I try to find out what are the key principles. And you mentioned various things. For instance, that benchmarks. You mentioned that the machine learning community they are basically making them up, and then this becomes self-fulfilling prophecies. We are making progress, although they define the benchmarks by themselves and stuff like this.
Yes.
And all comes down a bit to what Dagmar already mentioned, to how can we trust those systems, right? Trustworthiness of systems. And I mean, there are approaches in traditional software engineering, like for instance, formal verification, where you try to, like for instance, you formalize a precondition, and then you want to say that this system always behaves correctly, that under this precondition, this post-condition is always fulfilled, for instance, like this. And the problem with large language models and also general machine learning stuff, of course, is, as you already mentioned, it's all statistical based, right? There's also a generative AI tries to map this probability distribution that exists in the real world to some latent space, so there's some representation, which is like a compressed information of this real distribution, and then create something that fulfills the same distribution before. Okay, purely statistical. And approaches that try to apply formal verification to establish some trustworthiness of machine learning enabled systems struggle therefore with a statistical thing, because you want to basically exclude that certain states are entered or in the system. For instance, the robot does behave, the movement of the robot exceeds some parameter or something. Like you mentioned this example with the dog, who behaves always correctly. However, the robot, you cannot guarantee that he suddenly crashes, for instance, this shelf that he is in front of the rest. You want to exclude this possibility. However, because of its statistics with this LLM and Gen AI stuff, you get a lot of approximations. You say you need to, therefore, a lot of false positives. So basically, the challenge with formal verification of the system in general is the state space explosion problem. And now my question comes. I understood that your approach is basically first start with extracting some predicates, like first order logic, or maybe a higher order.
These are semantic predicates, not the concept of the predicate you were describing.
Okay. Semantic, but basically it's like Prolog, right? It looked like some statements that you phrase in a language like Prolog.
Yes, Prolog. Yep.
Logical programming language, and then you try to find an assignment that fulfills all those statements or something. So you have found a way to formalize how those entities that originate in this, that were phrased in this natural language statement, behaved, how to formalize their relationship with each other and stuff like this. And my question is, and then you combine this somehow with machine. And do I understand correctly that your approach is a way of narrowing down this search space, and therefore maybe we can overcome the state space explosion problem, and therefore this could lead a path towards setting up an approach to provide some formal guarantee for trustworthiness.
Yes.
And overcome this state-space explosion problem. Is this?
Yeah. So the big problem, if we just think of language and interaction with facts that are coming from some source.
Yeah.
The system that produces the answers should be disconnected from the testing of the system in this case. So if we look at the types of tests I've done so far, got 10,000 tests of put in this sentence and this is what I want to come out of it, or put in this conversation, these steps, this is the response that should come out of it. And because language is so variable, for any answer you give, you could provide me with 1,000 different ways of saying it. Mm-hmm. But at the meaning level, it's often just yes or no, and then you've got the fact there. So if you're testing the meaning that's coming out of your system, then you've got an accurate start. What words it actually generates can be handled separately. Mm-hmm. So the approach that we've taken is to say, if we start with language learning and you've got somebody learning the language and you ask these questions and they give these answers, if we can check that, great. Then we can add more difficult tests and more difficult questions. We then handle those. You can go into some particular domain like shopping. Can you handle all those questions? And at a period of time, you're actually at the point where this thing's coping really well with language. There's a learning step to be done where you need to learn new words on the fly. The Langenscheidt dictionary, I think, is well known in Germany, Langenscheidt. So one of the Roland Reference Grammar founders pointed me to this book, and in the book it explains about how many words are really part of the language. And in Silicon Valley, there's millions of words in every language, and that's why you need large language models, because you need to process the millions of words and build the vectors and so forth. But according to the Langenscheidt model, 66 words in the language is 50% of the words that we use. So that's, and the and but. And then once you get up to about 4,000 words, you're covering 95% of the language. So then the question is, what are the extra words? And the extra words are street names, people names, company names. So all of these language elements built on top of the language. So if I gave you a company like IBM, if you'd never heard of IBM before, but I tell you, oh, it's a company, and then I say, is it on the share market? Then you'd say, well, companies could be on the share market, and we can have a discussion about it and keep going. So my argument is based on what people know about languages being very small, with infinite extension. If we built something that was able to clarify what we're referring to, then the core system's going to work correctly. And so then the next question is, well, you can talk about any topic. So now start working on the topics and test them. And if your system's producing the right results for the questions that you're asking, you should be able to just keep building it. And it's not like you ever need a conclusion to this, because we're here at a university, and you teach people that don't know things new things. You don't teach them how the language works, you teach them the topics. So there's no reason we couldn't keep building through the university type process on our knowledge for machines, and then release it into the wild, and then just keep expanding ever onwards. And the advantage of machines is that they shouldn't hallucinate, they shouldn't lose information, because you can have infinite knowledge stored in a computer system, just more disks and so forth. So I think I'm sort of talked around your question.
I got the feeling that basically a lot of things are still clear to me about, but maybe this sounds like this could be some approach that could be worthwhile investigating further with. That goes in the direction of providing some guarantees or something.
Yeah, and the book's more at the lower level of why the brain works the way it does, but then I bring in some of the linguistics, which might be harder to follow, and then I talk about what I see. The chapter 18 to 20 talks about what the industry should look like to cover the types of things I just went through with. You'd have companies that are simply focused on a language like German, and not the knowledge representation or the meaning, because that would be a different area. But then once they plug together with a common representation, then you can check whether the German language is working correctly, and extend it for spoken versions as well as written versions.
Okay.
Otherwise, I've got to come back and talk more.
We buy a book, right?
Yes. And I have my pen as well.
Any other questions? Because some student had a next
Yes, of course, man. Session.
Yeah, and it's all the question. Oh, yeah, come.
If there is still...
Yeah.
Oh man,
Me.
okay.
I just really wanted to the share before.
Daniel would have made his day there, don't like that.
So my questions are going to be a bit more surface level, because I barely grasp the theory of it all. But if you had infinite resources now, so if we swap the places of LLMs and your approach right now, you get multiple teams over the world that are working on different parts of it. You get all the funding. How long would it take for your approach to catch up to where LLMs are now?
They're two slightly different areas of focus. So I present the model where we could have ubiquitous language systems in 5 years. And the big scaling step is getting teams for the different languages to make sure that their language works correctly. So it's the morphology and the phrases correctly being resolved into the meaning. And the types of interactions that humans have, or that we should have with machines, are going to be not the large language model problem. It's not tell me about nuclear physics or fusion and what do you think is the right next step in fusion, which is a very, you go to university for probably for 5 years or something to learn how to do the fusion part and then convert it into language. Whereas if you're interacting with a machine like my iPhone and I want it to report where I am, and it shows me what it shows me where I say I am, I could then just scan it and go, that's right. So suddenly we can interact with our machines much more naturally, and that's going to change how we do things. And having the feedback loop in it means that it's going to work. So it goes from being pretty good, what they say in Silicon Valley is good enough, to actually being good, and being on a forever improvement cycle where experts in that area don't have to understand the whole theory; they just understand their bit and they just make it better and better. And my experience in bit of a war story here, but when I worked for IBM, one of the things I did was I went to the Poughkeepsie manufacturing plant because I was a top engineer in Australia, and we were supported by a group of people in the US, and they were supported by people in this Poughkeepsie lab. And the Poughkeepsie lab was broken into groups that had product engineers that knew everything about an entire machine, but only one machine. And then you had the DE group that understood everything about one part of the machine, right down to the microcode that was written. And so if you had a problem, you'd start with a high level and then you'd just work your way down to the detailed level. And the guys that that designed the chips, you couldn't talk to because you had nothing in common at all. I knew the machine, I knew what it did, and they knew a chip and how they designed it. So in the same way, AI shouldn't be the type of thing where you're holding a town hall meeting and talking about how it works because it's too complicated. But you should be able to talk about something narrow that everybody cares about, like, what's this interface when I say this, it gives me that answer, and then I say that. How can we make that better? And those sorts of verbal interactions would be a good area, especially that everybody needs to know about, not the nuclear science example. So for me, the LLMs, the reason they're as big as they are is because that's the thing that made the language work as well as it does. But it's not really the factor that should make the language should be different. And so if we can focus on getting the language right and the context interaction right for everybody, it's going to be used so hugely that you'll have a big team of people just doing that, which makes everybody's lives better for most of the interactions, and a different group of people. Probably research first. You get experts in an area to work out the different ways of doing something. They make all the mistakes, They learn the 1,000 ways that it doesn't work, and the one way that does work is what's left. And then you can start to make that broader and more developed.
To kind of generalize.
Yeah. Right.
Those 7 killer apps, and he highlighted one of them, which is the language learning. So in parallel with getting the message out there, we've partnered with a pedagogist around language learning from China, and we starting to bootstrap those dictionaries we need to build for language learning, because the way that the natural language understanding system acquires its linguistics knowledge is like how, and Chris Lonsdale would say, the language educator would say, that's how a baby acquires their language. So we're bootstrapping the dictionaries to the point that we can with the funding that we're raising to build the language learning application. But those 7 killer apps are what John talks about in the book, about in a 5-year plan. Imagine getting this system going and how the impact that will have on no combinatorial explosion, it'll have accuracy, it'll be efficient with the efficiency of the slow brain. I have to mention that worked in one of these student research projects, developing a chatbot for our
Oh, fantastic.
university to give information related to some topics to international students. So he knows about the technical challenges getting there and working because of a lot of different limitations you have, not only from one technology, but also from the other.
Right.
Have the chatbot online.
Right.
Some students are working on that, and maybe to give information in a very narrow domain, but also trying to avoid the false information or hallucinations
Yes.
where the problems come down. So I wanted to mention that because, for example, he was more deeper in this area. Yeah.
Very surface-like.
Yeah. But it was an LLM implementation or
We're working with
oh yes, okay. Right.
and they have a way where you can just follow story paths, which is very guided. So it can't really give, and all the answers it can give are also just variants that are predefined. So no real like language model.
Right.
Behind that would be more interested to follow the pattern theory to develop a thing. So there is a lot that we can investigate in the academic domain with students try to learn from the one side new theories, new ways to try to put in machines this understanding, meaning the way we do humans, and a lot of ways for also working with the technology and learning other things also from the development of such systems point of view.
And I have two more questions that are very, very general and maybe more almost opinion-based, I guess. So if we're trying to create an intelligence that is emulating humans, should we expect that to perform always perfectly when we ourselves, I think one of the previous questions also touched on that, when we ourselves sometimes have bias or cannot recall knowledge perfectly, mistake details, like the example with Alan Turing not being at the conference. That's somebody who maybe isn't that familiar, who has read about Alan Turing and has read about the conference, but doesn't have the date of death of Alan Turing memorized, maybe would have assumed that that person at that time, because it's the same time period. So can we, should we expect from a machine that we create that is to emulate human behavior to be perfect?
I mean, my answer is if you're going to build a machine to use as a resource, you want it to work. And so we could emulate machines that don't work or humans that don't work, but then you can't use them for the purpose. So, you know, in your example of the chatbot system used for the university, you don't want it to produce the wrong answers because you can use an LLM for that. But if you can get to the next level, then it's just much better for everyone.
Yep.
And I think most of the limitations that we have is just our lack of memory. You know, we can't memorize 10 million facts like a machine can. So there shouldn't be a reason that the machine can't give us accurate answers, even if it qualifies it. Like, you know, the New York Times said this, and you know, the student council said that, and so this is the answer. Then at least you're giving a qualified answer that's as correct as the source. But today's LLMs don't include the source material as part of the training set, and so they can't qualify it as a human would. But ultimately, I'm not keen on the argument that, you know, well, people have limitations, therefore we, you know, it's fine that this machine doesn't work properly.
sounds like an excuse. As it sounds like an excuse for the machine not working properly. And the other thing is, again, very surface level, I read about scientists from England using mushrooms to create chips. And I think there is also experiments with the DNA bases to try to create a more efficient way to store information. And I wanted to ask, do you think like the limitations, especially like with vision and so on, is that we still don't have sensors, we still don't have cameras that are as high resolution as animal or human eyes, and obviously we also don't have the compute power still, I think, to properly analyze everything that is in the image. So, for example, the example with the dog, where the ground is sloped, your brain, I assume, automatically kind of it processes the information like, oh, okay, the slope is like that. So if I put down my leg, it's gonna feel like this. And do you think we should lean more towards the development of biomechanical chips and ways to process information than to stay with just the purely mechanical side, which seems to be slowing down in development?
Yeah, so on the robotics side, the idea of that's followed AI has always been around motors and human machines as the building blocks. And I've seen there's a company out there now through the internet that actually builds muscles and skin for machines and bones. If you're assuming that the brain is a computer, then why not just throw massive computational problems like, we'll have one motor to move this dimension and another motor to move that dimension, and just be able to process all of this stuff and then somehow coordinate it. And the problem is, I don't think that solution is easy to do with mathematics. Whereas if you look at animals, we control these streams of muscle contractions, and we handle the touch feedback that's coming from it, in the brain that we've got with the cerebellum doing all this work. I think it's got the most neurons in our brain, and people don't really have a model that explains what it does. So if one of the projects was to make robotics work like animals, you can imagine heaps of applications for that. And so it should be taking place, and it shouldn't have the limitations of, you must use this technology or deep learning or whatever. It might as well just be something that universities are developing. And then once you get the technology that aligns with brains to work, well, then you can start competing with other approaches. But yeah, I'm certainly of the idea that we need to spread these things more widely, not be narrower until it works.
Thank you.
Pleasure.
Okay. I think I have a question.
Bartur.
The fake not out the recording stuff now. Okay.
Okay.
Too much, John.
Yeah, that happened.
Is it like that? Yeah.